everyone, today we're going to work on the lowest common ancestor of a binary tree. Given a BST, find the lowest of two given nodes in the BST. So according to the definition, lowest common ancestor, so we have the P and Q. So we're just going to look at example. We have P is 2, Q is 8. And what is the ancestor, meaning the parents? The common parents will be 6, so the result is 6. That is simple as that. What is another edge case, which is if you have 2 and 1, you only have 2, and our P is 2 and Q is 1. Common ancestor will be itself, which is 2. Because right here we do have where we allow the node to be consistent of itself. I think initially we want to like traverse left and right because we tend to compare the P and Q to the one of the values. So what we're gonna do here, we're gonna start the root of the tree, and then we traverse the tree and compare the value of the current node with the P and Q. So we compare the current with P and Q. So let's say P and Q is greater than the current, the common ancestor must be on the right subtree. So it must be on the right subtree. And if it is smaller, it will be on the left subtree. How about if the current, I think it has to be between P and Q. So if it is between P and Q, we're gonna return root, which is the current node. So basically the fundamental of this strategy is to compare this P and Q with the current node that we traverse at. If it is more than, then we traverse to the right. If it is less than, we're gonna go to the left. And if it is in between, then we gonna guarantee is we're gonna traverse to the root. Okay, let I comment it here. If both PQ is smaller than the value, the current. And the other case will be PQ is greater than the current, and if they are in between. So let's say as P Okay, so if the PQ is less than the current, we're gonna go left. Other, we're gonna go right. If root dot value is greater than P, and also root dot val is greater than Q, because our testing the value, so we have to do the P dot zero. We're gonna tower left, so root, we go to root dot left, just try to find, gonna copy the same. This is our reverse way. I'm just gonna go to the right. Return root. This is the last case. Okay. Submit. What is the time and space complexity of this question? So the time complexity would be O of log n. To insert the balance tree, right? So that is the height is log of n. And what is the space complexity? O of 1, because we didn't use the amount of space. Doesn't matter what is the input side it is. See you next class.